All right, we're in section 10.1 on radical expressions and functions. So objectives are introducing radical expressions, then recognizing square root functions and their properties, and then recognizing cube root functions and their properties. But we're also looking at just the nth root functions as well. So a square root. So the number b is a square root of a if b squared is equal to a. Okay. And so basically what we've done is we said, okay, well, if we have the square root of this and the square root of that, then b is the square root of a because the square root of b squared is b, and then that's the square root of a. So that's how we're going about this. Now, the key thing is when we're taking square roots, the ones looks like just like this, just a square root, it has to be a positive number. So we can't do negative numbers under the square root. Okay, if we have a negative number under here, we're getting into things called imaginary numbers, and that's not what we're looking at in this section. So every positive number a has two square roots, one positive and one negative. Now recall that the positive square root is called the principal square root, and that's usually the one we're looking for. But sometimes they just ask us to find, plus or minus a square root of something. Now the symbol, which is the radical sign here, is called the radical sign, and so that's what it's going to be. So that means a square root. Now the expression under the radical, so what would go under here is called the radicand, and the expression containing a radical sign is called a radical expression. So a radical expression could be the square root of 7, or 6 plus the square root of the quantity x plus 2, or the square root of 5x divided by 3x minus 4. So all those are radical expressions. Now it says evaluate each square root. So the square root of 36. Well, if we know our perfect squares, that's just going to be equal to 6. Okay. And because we know that if we have 6 squared, that's 36. So if we take the square root of 6 squared, that's just 6. Now, what about this one? Well, this is a little harder because now we have to think about this as, okay, well, now we have 64. We know the square root of 64 is 8, but we have two decimal places. And so when we multiply decimals, we add them together. So this is going to be zero point 0.8 as far as our thing. Because if we take, 0.8 times 0.8, that's going to be 64, and we move it one, two decimals, and that will give us 0.64. Okay, so we have to think about in terms of when we have this, we have one less decimal as far as our answer will go, and then we just have to think about what is the square root of the 64. Well, that's the 8. Now here we have a square root of a quotient, and so we're going to look at the square root of 16, which is just going to be 4, the square root of 25, which is 5, and so we just get 4/5 as our solution here. Again, knowing our perfect squares usually helps in this section. If we don't know those, have them so we can get to them easily or have a note card or something that we can look at those. It will help us a lot. What if they want us to approximate the square root of 38 to the nearest thousandth? Okay, well, that means we're going to plug it into our calculator, and depending on which calculator you have, it looks different. But basically, you're going to hit the square root sign, and then usually it puts the first parenthesis, then you hit 38, then you hit the end parenthesis, and then enter, and it gives us this. So to the nearest thousandth, well, that's going to be the third decimal place. 4 doesn't round it up, so it's going to be 6.164. So that's going to be our square root to the nearest thousandth. All right, so let's stop there and we'll come back for some more.